Hi students, today we will discuss a multi-conceptual question which is related to functions, strictly increasing and decreasing functions and differentiability continuity, which is given in JEE Advanced Exam 2023. The question is, let S equals to the intervals 0 to 1 open interval union, open interval 1 to 2 union, open interval 3 to 4. So that clearly need to understood that S contains infinite number of values, infinite number of elements, because of from 0 to 1. Anyway 0 and 1 excluded, but in between 0 to 1 there are impossible infinite number of values are there. So S contains infinite number of values that we have to keep in mind, and T equal to the set of values that contains only 4, that is 0, 1, 2, 3. T contains only 4, second set contains only 4 elements. Then which of the following statements true? Then the first option is there are infinitely many functions from S to T. Now coming to the solution, so based on the first option, like S equals to, they given is like what they given, the intervals 0 to 1 union, 1 to 2 union, 3 to 4. That S contains infinite number of elements. For suppose if you want to say that S n of S equals to m, then m tends to infinity, right? And what about T? T is a set which is having the elements of 0, 1, 2, 3. Then n of T is equals to, for suppose n, then n is equals to what? 4. Now as we know that the number of functions from S to T is n power m, that is what here 4 power infinity. Now that 4 power up to is like m tends to infinity, right? Then for suppose if you want to say like this, then it is what approaches to infinity, then there will be infinite number of functions. From S to T. Okay, so the first option is right. Now there are infinitely many strictly increasing functions from S to T. See here that infinitely many strictly increasing functions. So if it is a strictly increasing function, first of all we want to know that what is strictly increasing function. For suppose if x1 is less than x2, that implies f of x1 is less than f of x2, then only we can say that it is strictly increasing. Then here in such a cases, if x1 less than x2, then f of x1 less than f of x2, like function value of x1 is always less than function value of x2, then only we can say that the function is strictly increasing. So that if you check the intervals from 0 to 1, which is less than always 1 to 2, then in this case f of that function value of that interval 0 to 1, which is always less than the function value of that interval 1 to 2, right? Means if you check the possible cases, like the function value of 0 to 1, if it is 0, then it should be either like 1, 2, 3. And one more thing is like function value of 1 comma 2 is less than function value of 2 comma 3. Then if the function value of 1 comma 2 is 1, then the function value of 2 comma 3, sorry, it is like 3 to 4. The function value of 1 comma 2 is 1, then function value of 3 comma 4 is either 2 or 3, then only we can say that function is strictly increasing. For suppose the function value of the interval which contains 1 comma 2 is 2, then the function value of interval 3 comma 4 must be 3. So these are the only restricted possible number of cases, which is nothing but finite, because of second set t contains only the elements 0, 1, 2, 3. So in this case, because of t contains only finite number of elements, there is no possibility to get infinitely many strictly increasing functions from s to t, because of these are the only possible cases here what we are observing like this. Like, and function value of 0 comma 1 is, for suppose let's say 1, then it should be 2 to 3, like that. Only restricted number of cases, not which is not infinite. So option B is wrong. Now move on to the option C. The number of continuous functions from S to T is at most 120. At most 120. The number of continuous functions. Now, if you observe the sets, S is 0 to 1, 1 to 2, union 3 to 4, and T equals to 0, 1, 2, 3. Now we just want a continuous functions. Clearly, if you want to get a continuous functions, like it is from number of continuous functions from S to T, in that particular interval, we can say in that particular interval, because of if it is in the interval 0 to 1, there will be a continuous function, but it's not from the entire set S to T, because of what, 0 to 1 and 1 is not included, there will be graph is broken, so we can't say it is continuous. So for suppose if you take the intervals, it is from 0 to 1, we have 4 possibilities that make the function continuous. Like, in between 0 to 1, the value will be either 0 or 1 or 2 or 3. Means, like, f of 0 comma 1 interval, the function value of that interval is like either 0 or 1 or 2 or 3. Means f of x equals to either 0 or 1 or 2 or 3. Means here, if you observe this one clearly, f of x equal to 0 is a constant function, f of x equal to 1 is a constant function, 2 and 3. So that in that interval from 0 to 1, whatever may be the value, you can substitute, then you can make the function continuous, and it is a constant function. Like, if you say, for suppose it is from 0 to 1, then if I say that it is f of x equal to 0, then the function is like, here it is 0, it is a representation of f of x equals to 0. So here we can observe that in this interval 0 to 1, the function is continuous. Like, for suppose there is another possibility that f of x equals to 1, then if I say that it is 1, then there will be another possibility, either this is the another case for in the interval 0 to 1, or this will be another case, or this will be another case. So for every interval, like here, how many intervals are there? 0, 1, 1 to 2 and 3 to 4. For every interval there will be 4 cases. Like, here for 0 to 1 there will be 4 cases, for 1 to 2 in this interval also there will be 4 cases, or from 3 to 4 there will be 4 cases. So number of continuous functions clearly is equals to 4 times of 4 times of 4, that is equals to what, 64. Then here in this question, what they given is the number of continuous functions from S to T is at most 120. Here at most, maximum possibility is 120. Here we got 64, and so number of continuous functions is possible. Then option C is a correct answer, because of at most 120. So number of continuous functions 64 for this question is correct, because of 64 is inside of that 120 only. Next, move on to the option D. So every continuous function from S to T is differentiable. It's a very clear and easy question that every continuous function from S to T is differentiable. If you get to know what is C, then D will be very comfortable to you. That is, if you observe that C, every continuous function, if you observe that continuous function in the interval from 0 to 1, it's a constant function, right? 0 to 1, what is that? A horizontal line which is not strictly increasing. Then based on that C also, we can say the function is not strictly increasing, like option B is wrong. And now C, if you observe, the function is continuous, it is a horizontal line. Note what is the derivative of this is f dash of x every time is equals to what? 0. Whenever the function is continuous in the particular interval like 0 to 1 or 1 to 2 or 3 to 4, then we'll get like horizontal line to make the function continuous. So that in case of horizontal line, the slope is 0, means f dash of x equal to 0. Now based on that, every continuous function from S to T is clearly differentiable and the derivative is equal to 0. Whatever may be the function continuous in the interval, f dash of x is clearly equal to 0. So that option D is wrong. Now what are the correct answers are A, C, D. Thank you.